Hi, I'm Paul Poirier, local architect. Most of you guys know me, but today we get to have Amy Leadham give us a presentation. And I met Amy, I'd say probably about 5 or 6 years ago when I was working on the 2030 commitment work group with National AIA. And I've always been impressed with her depth of knowledge. She's incredible. She knows all kinds of stuff about PEUI, and I'm glad to see she's leading the charge on embodied carbon. So I'm really looking forward to hearing what she has to say about this. Amy's an associate of Atelier 10 San Francisco office, and she's a registered architect, combining her expertise in building physics and architecture to provide sustainability visioning and analysis to design teams. She's been successfully managing projects of all scales with a wide range of ambitious goals, including net zero energy, net zero waste, occupant health, and embodied carbon. Amy leads Atelier 10's carbon practice and has greatly advanced the firm's approach and process to reduce the carbon impacts of their projects. I'm looking forward to hearing from Amy. I know a lot of you are super committed to the environment, and we have a long history of AIA Santa Barbara doing that. And I know embodied carbon we're really not up to speed with it here in town. And we're looking forward to hearing from you, one of the smartest people on this topic. So thank you so much for coming to talk to us, Amy.
Thank you, Paul, for that very generous introduction. I will start sharing my screen. And there we go. Put you all back so I can see. Okay. Yeah, so again, thank you, Paul. It's really nice to be able to join you all. I think Paul covered the introduction of me. I think one of the key things I always like to highlight is that I am also an architect. So even though I focus entirely on sustainability now, I do come from full architecture education. I worked as, prior to getting licensed, an architectural designer for many years. I understand all of the design related issues, but also then, can understand what the engineers are saying. So I like to say that myself and my colleagues at Atelier 10, we really provide that translation and connection between engineers and architects to really bring engineering and design together for sustainable solutions. So for those of you who aren't familiar with Atelier 10, which is where I work, I just wanted to give you a really brief intro into us. We are an international consulting agency. We really focus on the fact that buildings and landscapes do more. We try to have the buildings and landscapes do as much as possible before bringing in the systems. Designing from first principles, really focus on integrated design process and integrated solutions, and pragmatic strategy is also really important. So we do everything related to sustainability pretty much, from environmental design, facade, daylight design, a lot of benchmarking, LEED related work, master planning, energy analysis. Internationally, we do MEP engineering, so all of the things related to sustainability. As Paul mentioned, my primary focus is within carbon. So I run our carbon practice, really strong focus on embodied carbon, but the thing I'm going to talk about today is really this concept of absolute zero carbon, which is something we've been focusing on. We've kind of shifted our efforts, and I'll talk about why, to absolute zero carbon and why it's so important. So some big, bold stuff to start off with. We've been hearing this for years now, right? IPCC has been coming out with new reports kind of every year, every 2 years, getting more and more direct and kind of panicked if you read between the lines each time. But fundamentally, we have 7 years left to avert the worst impacts of climate change. I think the latest report came out, said there's like a 40% chance that we'll stay under 1.5 degrees Celsius. So the window is closing. We know that our industry, the design and construction industry, is capable of change to solve this environmental crisis. We've done it before, but we really need to do it again. And we really need to do it more quickly and radically. I think the thing that a lot of folks in the sustainability side of the building and design industry, you know, we've been talking about this for a really long time. We've seen some change, but it's just been really slow, right? It is hard to steer a large ship and change course, but we really have to figure it out. So our approach is that we really need to be at absolute zero carbon as soon as possible. And so I'm going to talk about what that means. I think the thing that we've had some really interesting discussions about over the years at some of these meetings that Paul and I were at AIA National about how to message and address sustainability related issues within the full breadth of our industry in the US and all different practitioners. And it was really interesting because it wasn't that long ago, I'd say maybe 4 years ago, there was a large meeting in DC, like really to get a roundtable discussion to figure out what the approach would be for the AIA. And even though everyone agreed that carbon was the thing, no one at that time, most people were not really compelled by carbon as something to get people's juices flowing, right? It was really about the other more experiential related items that also sometimes align with reducing carbon emissions. But like carbon itself was not compelling enough for most people. I think that's shifted. It's starting to shift. I think there's still a lot to messaging that needs to happen, but it's really interesting because in the past 4 years, in our experience, more and more of our clients are coming to us, and the thing that they care a lot about is carbon. They definitely still care about user experience and occupant experience, but carbon is almost equivalent. And so I think it's really compelling to see that changing. That being said, our approach to carbon and all things sustainability is really always tying it back to other co-benefits. So this is our roadmap. I'm giving it away early. We'll talk about most of these in a bit more detail. But we're taking the approach that every building, every development, every master plan needs to address all of these things. And it's not rocket science. Like, we're not really proposing anything new. We're just trying to piece together all of the little things that we've been working on different projects and different scales, and just kind of like synthesizing it into one approach that everybody has to do all the time. So radically passive all electric design, right? Not rocket science, especially in California. We've been pushing this for a while now within the state. This obviously has a lot of co-benefits with resilience and wellness. We know passive design is also really aligned with passive survivability. Really prioritizing adaptive reuse. That's as good as new construction on operational carbon and better on embodied carbon. So again, I think folks in the industry have been really passionately saying, like, let's not build new unless we absolutely have to. And I think we're just bringing that to the front and center. 24/7 renewable energy, so that a project is never relying on fossil fuels, even when it's connected to the grid. So we're going to talk about this one in a bit more detail today. But this also has resilience co-benefits. Really prioritizing carbon sequestering materials. This has a lot of co-benefits for ecosystems, waste, toxicity, and environmental justice. Serious protections for functional ecosystems and landscape, and rehabilitating developed landscapes so that they sequester carbon and support habitat. So for a lot of projects, this goes beyond the scale of an individual project. That being said, a lot of the development that's happening, building that's happening around the country, isn't necessarily in super dense urban areas, but is in the fringe, right? And I think it's really a good prompt to think about where we're building and how we're building. And then the last piece is a really serious attention to transportation. So again, maybe not super addressable at the scale of individual buildings for every project, but definitely addressable within master plans and city planning, and a really key piece of the puzzle. So another lens that we've taken when talking about absolute zero carbon, it's kind of looking at the same information, but in a slightly different way, is a lot of the discussion has been focused on what we're seeing on the right. We've been focusing on net zero energy, which is then translated to net zero carbon, which is really all about electric power for operational carbon, right? That's like been a lot of the discussion in the past 10 to 15 years. In the past 5 years, I would say, and even more recently in the past kind of 2 years, the focus has started to shift towards embodied carbon, which is great. I think that's really important, especially when we look at short-term carbon emissions, right? Embodied carbon gets locked in when the material is produced. But we've really been limiting most of the discussion, most of the focus to structure. So when we're talking about the carbon impact of a project, we've been really, it's great. It's great that we talk about operational carbon and all electric, and it's great that we talk about the embodied carbon of our structures, but we're really leaving a lot of the kind of key levers that we have to reduce the carbon impact of projects off the table. So that's really what we're talking about when we talk about absolute zero carbon, is look at everything for every project. Obviously, the opportunities, challenges, and limitations will be different for every single project, but we really should be evaluating and understanding the impact of each of these for every project. So this is a continually evolving process, and it's a very rapidly evolving kind of aspect of our industry. So kind of the current things that we're seeing that are already changing, right? We've seen pretty good advances in energy conservation through better insulating products, just passive design kind of having a comeback, and electrification expanding around the country. So not just in California, but New York has and Massachusetts have natural gas bans, as do other places around the country. Embodied, right? We've seen a lot of focus on structure and foundation. Concrete especially has had a lot of focus on reducing embodied carbon. We're starting to see more focus on envelope materials. And then in transportation, right, we've seen just a pretty big uptick in electric vehicles and their energy use and how they're charged. So these areas have been changing and are in development. It's really great to see. But we also wanted to identify what else we need to look at and what's next. So on the operational side, right, it's 24/7 renewables. Again, I'll talk about that a bit more later. Energy storage, right, batteries are becoming code for certain projects in California, and a really important piece of the operational carbon side of things, and the technology is advancing quickly, but there's still a lot to figure out. Refrigerants are really important, and carbon capture is, I think, just a realistic aspect of the future of a carbon neutral society. On the embodied side, it's basically everything else in the building. So continuing to advance envelope, but really looking at interiors, MEP, lighting systems, the construction process, infrastructure, landscape sequestration, sequestering materials, material waste reduction, and designing for end of life. So there's a lot there. And then on the transportation side, really looking at energy storage. There's some really interesting alignment between electric vehicles, electric charging, and battery for buildings. Mass transit, obviously, alternative transportation, and the transport of goods and shipping is really also very important, and is somewhat tied to buildings because of where we source our materials from. I'm going to skip over that one. Okay, so that's the big picture overview, what we're talking about when we say absolute zero carbon. I'm going to start with some of the operational carbon items that I think are the most critical to talk about. So I think a key thing to start off with is as we're getting more sophisticated, as carbon is becoming more of the driver, I think it's really important to be clear about definitions. So net zero energy was the thing for quite a long time, and it was really a proxy for carbon, right? yes, it's really beneficial to reduce energy consumption on site in terms of reducing energy cost, but the big drive to reduce energy was really related to carbon emissions. And so there's lots of different ways to define net zero, but we're really talking about net zero greenhouse gas emissions. And I think it's really important to know that that does not necessarily equate to net zero energy. So I think a key thing is that it's possible to have a net zero energy building and still use natural gas. It is not possible to have a net zero carbon building and still use natural gas, right? So it's not a one-to-one, which I think is an important place to start. The way that we're talking about net zero carbon is not even necessarily at an annual average metric, the way net zero energy is often talked about. We have been focusing on this concept of 24/7 carbon-free energy. And really, it just means that every single kilowatt hour of electricity consumption is met with carbon-free electricity sources every hour of every day. So a standalone project, individual building that has on-site energy generation that's not connected to a grid would be 24/7 carbon-free, right? Like those projects are challenging in order to make sure you have enough energy to meet your peak demand. But those kind of bespoke dual box standalone grid disconnected projects are 24/7 carbon free. The reality is most of our projects, even if they have on-site renewable energy, are connected to the electric grid, right? And so then they're really beholden to the carbon intensity of that power source. And so, oops. All right, here we go. So what this is really, this little GIF is showing is, you kind of follow the up front here, the titles. Basically, the green is times of day and year when the grid is clean, if you will. And the red is when it's more carbon intensive. And so really what this is showing is the impact of different levers that we have as designers to get to a point where the box is entirely green. And as you see, we don't quite get there. But it's really a combination of on-site renewable energy and battery storage. We'll talk about that in a little bit more detail, but being able to use the grid energy when it is renewable and carbon free, and being able to not rely on the grid when it is most carbon intensive. That's fundamentally what it's about, and we'll talk about how you do that in a bit more detail. The first way, this is this idea of the first principles, but again, I'm certainly preaching to the choir here, I'm sure, but really starting from reducing the energy demand of building as much as possible through the architecture and passive design. Again, not rocket science. We've all learned about this in architecture school. I'm sure we all practice it on a daily basis. But I think with this shift to really talking about carbon neutrality and sustainability, a lot of focus gets put on technology to solve the problems for us. And I am a part-time lecturer, and all of the architecture and developer students that I teach, they're always asking about the cool new technology that's going to save us. And I think that's like our tendency as humans, is to go there. But as architects, we all know that these basic principles of passive design are really one of the key strategies we have in our toolbox to solve this issue. So, and they're kind of the most fun because we get to control them as architects. So nothing new here, but right, massing and orientation, design for daylight, design for natural ventilation, robust envelope and shading as appropriate. And the point of the chart on the right, or the left, sorry, is to show how much of our typical building energy consumption is really influenced by the design of the architecture, right? So it's like just driving home how much impact we can have through our design. And once we've done as much as we can with the architecture itself, then obviously we will need systems and we will need on-site renewable energy, but those problems get a lot easier to solve when we make the architecture do as much as possible. Again, I don't think that this is, I think I'm preaching to the choir here, but a lot of clients often kind of balk at the idea of increased insulation because of a cost issue, or increased glazing performance because of a cost issue. But I think this example is really important because it shows that sometimes, if it's done right and integrated design and coordination is really fully functioning within the design team, you can actually end up saving first costs. So this is just an example of a project in the Bay Area, a kind of private office building, relatively small size. But they put increased insulation, they put high performance glazing. So they actually put triple glazing in this climate, which is rare, but it ended up saving. So it increased passive survivability, which we've talked about, right, the resilience. It resulted in operational cost savings, so lower energy bills and fewer complaints. It actually resulted in upfront cost savings. So if you just look at a one-to-one, yes, the triple pane glazing was more expensive than the double pane glazing when you compare them to each other. But when you look at the more holistic impacts of what that triple pane glazing allowed, which was a reduction in the mechanical system by eliminating the entire perimeter heating system, they actually saved money. And because they were targeting net zero energy, that lower operating energy meant that they needed a smaller PV system. So it was like even more bonus. So this is really just kind of a little tidbit to show that taking that more holistic view of everything, including project cost, can tell a more compelling story for some of these strategies. So some of the things I've mentioned already, we're going to dive into a little bit, looking at all electric considerations. So we've talked about load reduction. Other areas to focus on the building is demand response. So this is being demand response ready is required by code in California for certain typologies, and it basically just means you have to be able to shave off peak load for certain end users if the grid is being stressed. Direct DC power is something that is also really helpful. It allows you to directly use the energy generated by your PV on your site without having to convert it and end up with some losses. Cooking is really an important electrification discussion, thinking about the demand for EV charging. We've seen this that can add up to 20% load and peak load. And then obviously renewable energy generation. And then, sorry, depending on the scale of your project, thinking of district scale and grid connections also really important. So thinking about energy storage and microgrid. So I'm going to have a little discussion on a microgrid in a second. And then controls. Controls is a really important piece of this. And again, I'll have an example in a second to show why. So when talking about electrification, just diving a little deeper, right, this really means electrifying domestic hot water, space heating, food services and cooking, and laundry. So domestic hot water would be switching from a boiler to a heat pump, for example. Space heating would be switching from a boiler to any type of heat pump or VRF system. Food service and cooking is one that we often get the most pushback from, especially from corporate clients, but induction units, there's lots of good research out there now to show how the co-benefit of interior air quality and health from switching to electric cooking, and the really good induction units that are kind of equivalent quality to gas, to the point where Microsoft and other really large tech companies have switched to fully electric cooking, even for their large cafeterias. And then obviously electric dryers, not that one's probably the easiest switch to make from a user experience point of view. So then thinking about renewable energy, obviously the preference is for on-site renewable energy, but not every project is going to be able to do that. Many projects are overshaded or require, significant rooftop equipment, and so don't have a lot of space for it. And frankly, most of the larger projects are not going to be able to have enough space on site to generate enough power. So then we're really going to offsite renewable energy. And we've kind of classified it into 3 tiers. And every project's going to have to do this kind of due diligence for themselves, but I think some things to look for are additionality is the term for, the program that you're signing up to results in new renewable energy. It's not just buying RECs. That would be tier 4. But I think each region is going to have different options available, some from the utility and some from private solar developers, but really kind of understanding the options that are available for your project to opt into off-site kind of carbon-free energy. I think a lot of folks here are probably familiar with the standard on-site roof-mounted PV. But I think one area that is developing quickly, and as projects are trying to generate more energy on site, is becoming more of a design issue as well, is building integrated PV. So there's lots of different ways to do it. We're kind of showing here the range from, generally speaking, unfortunately, the options that have the most meaningful production, which are on the 2 ends, maybe have the least desirable aesthetic impact. And where we stand now is the kind of products that are in the middle here that are more easily integrated into a facade, and maybe actually have a really positive aesthetic impact, for now anyway, are not generating as much power as some of the kind of more traditional panels. But I think this is a space to keep watching. Feels like we see new products coming online all the time here. Batteries are the next piece of the equation, as we talked about. So I think no matter the scale of the project, an on-site battery is really helpful for resilience, in terms of avoiding power disruptions. We have been seeing kind of increasing wildfire related or grid stress related power disruptions throughout the state of California. And so battery really makes a lot of sense, especially I would say for smaller scale projects, where the power demands are less and the system can be contained to a relatively small area. There's lots of different ways to size your battery, but the sizing it to offset a peak demand would be, very different than an approach that would be sized to meet 24/7 carbon free. You would need more, like a much larger battery to have more power to draw from in order to not rely on the grid kind of during times when the grid is carbon intensive. So this is the example that I kind of wanted to talk through that shows, some of the, at a diagrammatic level, some of the way that these systems are connected to each other, and then the control that's required in order to interact with the grid and interact with your battery system. So this is for a private college in San Francisco. But it's not a huge building, but it's fairly energy intensive. It's an art studio. There's art studio program in it. So they've got on-site PV, and they are connected to the utility grid, but they also have an on-site microgrid in order to be able to kind of disconnect from the grid when necessary. And there's a lot of numbers here, but really the main thing is the graphic at the bottom, which is kind of showing how on a daily basis, they're really leveraging the PV system and the grid and the battery to be as carbon neutral as possible. So it's not operational yet, so not sure if they are operating fully 24/7 carbon free, but basically this is showing a typical day. And any time that it's not, that the color isn't green, the grid is dirtier, we'll say, right? Higher carbon intensity, and it's because of the fuel source that's being used at the power plant to generate the electricity, and that fluctuates throughout the day based on demand and availability of resources. But basically, it's overnight and in the evening, when demand is high and renewable resources at the grid level are low, that the grid is the dirtiest. And so during those times, the building is drawing its power from its battery. And then during the day, when the grid is cleanest, and the PV generation on site is highest, they're charging the battery from their PV before sending it to the grid. And so, right, this is the type of granularity you need to size your PV and size your battery and set up the controls to be able to operate in this way. So switching gears to embodied carbon, I think just to start with some general definitions. I'm sure most folks are familiar with what embodied carbon is, but it's really just the carbon emissions that are associated with the materials used in the building. I think the thing that can get confusing is there's a lot of different ways of talking about it. And it's related to the stages of a product's life cycle or a building's life cycle that are included in a discussion. I think that the kind of three primary are here. So there's for products, a lot of times when people are talking about the embodied carbon of a specific product, they're really talking about cradle to gate, so A1 to A3. So it's really kind of the emissions associated with the extraction, transportation, and manufacturing of that product. When people are talking about buildings, most often they're either talking about upfront emissions, which is everything right up until the building opens, or they're talking about life cycle emissions, which includes the full service life of the building and some of the end of life considerations as well. Obviously, a lot can happen to a building during its service life. And so I think it's really important to be clear when talking about embodied carbon and impact and carbon drivers, whether you're looking at the upfront emissions or the life cycle emissions, because the story can change depending on what you're looking at. So at Atelier 10, both on the energy side, but also on the embodied carbon side, we really try to use embodied carbon assessment as a design tool. So I think it's really valuable to do embodied carbon analysis or accounting at the end of a project just to kind of understand what happened. But I think from our perspective, the ultimate goal is to use it as a design tool to help drive design decisions. So this is just a summary of our overall process, which again, it's not rocket science. I think it follows a typical design process for any issue, right? Which is early on, you want to figure out if you have a target, if you're going to be doing any certification, right? Certain certifications are address embodied carbon and life cycle assessment, and those are important to know upfront if those are going to be part of your pathway, and identifying reduction in design opportunities. Early in design, we like to identify carbon drivers. So these include, right, the massing. Massing can be a big impact on overall embodied carbon, the structure of the envelope. As these big design decisions are being made, being able to have embodied carbon be one of the criteria that's evaluated in addition to cost and aesthetics and constructability, et cetera. And then through mid-design, really switching gears to, okay, we've got the big decisions made. Now, how do we work on the less, the smaller decisions that still add up to have big impact? And really talking about things like constructability and procurement, because that's the follow through, right? That's part of the follow through. And then towards the end of design, doing final calculations, any lead submission, supporting any offsets that are required, definitely doing follow through in terms of submittals and CA reports to make sure that what the design team said wanted to happen is actually happening. So how do we set embodied carbon goals for projects? There's a wide range. So I think in general, this summarizes our thinking on it, but from our perspective, a baseline would be having some low carbon specifications. There's really good resources out there from the Marin County Low Carbon Concrete Code, even the Buy Clean Act for California has some good GWP thresholds. That would be a really good place to start. Doing a life cycle assessment. Again, at the end of the project, when you have all the information to understand where you are, we would consider that baseline as well. Kind of one step up from that would be targeting a reduction in embodied carbon. So LEED V4.1 gives points for documenting a 5 or 10% reduction for a new building. There's also interiors credits if it's just an interiors project. If it's an entirely new building, adding an interior assessment, which is not required by the new construction LEED credit, would be another good option. I think a step up from LEED would be the ILFI zero carbon certification. So they're going for at least a 10% reduction, and they also have a total embodied carbon cap for a project, and they require carbon offsets. And then the most aspirational would be zero embodied carbon. So it's going for, it's kind of taking the ILFI zero carbon and going all the way. So including more in the assessment and reducing as far as possible. So another way of setting carbon target gets a little bit more granular. So we just saw on the previous page, the ILFI has a embodied carbon intensity maximum of 500 kilograms CO2 per meter squared. So it's kind of like an energy use intensity number, but it's just for embodied carbon. I think it's really helpful because it's right project and site and structure system type agnostic. But I think it's really interesting to look at the lens of the fact that different size of buildings and different construction types have quite different ranges of what's currently achievable and what's kind of currently industry standard. The other way to look at this is from a planetary boundary perspective. So we've done a calculation based on the global carbon budget and the percentage of that that is building related, and have calculated that every single building on the planet would need to standard 185 kilograms CO2e per meter squared between now and 2050 in order to stay under 1.5 degrees C of global warming. And so when you put that over this bar graph that's looking at the embodied carbon intensity of different building types and structure types in size, it gets really interesting. You kind of start to see that the only thing that's currently achieving an intensity lower than this 185 is all looking at wood-based construction. So whether it's wood frame or mass timber, which is an interesting challenge. So kind of going through our process a little bit, talking about carbon drivers, it's really helpful to see where carbon is going in a building. So this is, again, more holistic. So this is in the lens of our absolute zero carbon. We wanted to include things that are typically excluded. So we've added interiors, MEP systems, and FF&E to really understand the distribution of embodied carbon. This is for a typical steel framed building. So just a specific example. You know, you can do this through a consultant. You can do this through your own data. There's a couple tools out there, open source tools that can help with this a little bit. Epic Tool and Care Tool, I put them here. One's for new construction, one's for renovation. I'm sure there are more, but there's a lot of open source tools that at least give a sense of some of these things early on. It doesn't have to be a huge undertaking. So when we look at that previous graph, or previous chart, where are the biggest reduction opportunities that we're seeing? So this is pretty generic across kind of all building types and sizes, but using mass timber or other wood-based structural members tend to have the largest impact. So this can be anywhere from a 15 to 50% reduction, depending on whether it's a hybrid system, a fully mass timber system, lots of variables there. But it can come with a cost premium. Doesn't always have to, though. I think there's some really interesting reports coming out of the recent mass timber conference that have looked at the cost premium of mass timber for several projects, and some actually showed a cost savings because they were able to realize construction time reduction pretty significantly. Others still had a cost premium because it took them a while. The first couple buildings, they didn't necessarily know what they were doing super well on site, and so they didn't get to realize the schedule savings from using mass timber. Concrete optimization is a huge one. Again, there's a lot of efforts around not only the state of California, but around the country to really focus on concrete reduction. So again, depending on the type of building and the region, we've seen this be anywhere from a 5 to 30% reduction. So the 5 is more when it's a steel building that has some concrete, for example. 30 is when you've got a full concrete building and are able to push your mixes in terms of GWP. And surprisingly, this tends to have a really minimal cost premium. These are all project budget cost premiums. Steel procurement and rebar procurement. This is really about selecting products from specific manufacturers that have demonstrated lower carbon products, whether usually it's through the use of higher recycled content and on-site renewable energy at the plant where it's being generated. I think the three on the right are often overlooked, but interior finishes, insulation selection, and facade materials tend to have minimal cost premiums. Some can have higher, but especially when added together, they can be as impactful or more impactful than some of the structural system decisions. And especially if you do all of these together, you can get pretty significant reduction. Talking about structural system, just looking at steel versus concrete versus mass timber, kind of generically looking at what is today's industry standard versus what's today's best practices versus what we see coming down the line based on the technologies that the different material types are looking at. And I think we see long term that steel and concrete might get pretty close to each other in terms of embodied carbon performance, but generally speaking, right now we're seeing that the concrete industry has kind of more ability than the steel industry to reduce embodied carbon on projects. We are also seeing that mass timber is pretty much always significantly lower than steel or concrete. That being said, for mass timber, really important piece of that is sourcing from responsibly managed forests. So protecting the old growth forest and those intact ecosystems, but also just supporting ecosystem in general, right? So there's a lot that you can do around timber sourcing. I think that it's a very contentious area. I think every project has to figure out for itself what its kind of timber requirements are, but FSC can be a good way to ensure a pretty high standard of sustainable timber, but it's not the only way. A lot of projects have foregone FSC certification in favor of just having discussions with the suppliers to understand where the wood is coming from and kind of see the impacts for themselves about where the wood is coming from and make the decision that way. Concrete optimizations. So primary way that this is being achieved right now, reducing embodied carbon in concrete, is replacing with alternative or supplementary cementitious material. So it's the cement that's really the kind of big carbon emitter in concrete. So replacing cement with slag or fly ash are kind of the two most popular around the country still, is a really successful way of reducing the embodied carbon. Using higher quality aggregate. So this is another one where looking at cost holistically is important, because if you just compare a high quality aggregate to a less high quality aggregate, the cost is going to be higher. But what using a higher quality aggregate allows is the use of less cement, which means you have to buy less cement as well. And so oftentimes it comes out to be either cost neutral or even a cost savings. We are seeing different ranges around the country depending on kind of market familiarity in terms of percentages of cement replacement. But again, you kind of have to figure that out on a project by project basis. Type 1L cement is an alternative product that, again, its availability changes depending on where you are around the country, but it's just less carbon intensive than kind of normal cement. And then there's quite a few technologies kind of coming down the line that have claims about how much they reduce embodied carbon, but I think that the future is promising within the concrete industry. For steel, it's much harder to write specifications to achieve steel embodied carbon reduction, just because sourcing and schedule and cost are obviously the biggest drivers, and it's not as much of a localized thing as concrete. So our approach is to write specs that prioritize U.S. domestic steel that comes from electric arc furnace that has high recycled content. So this approach just weeds out steel from plants that have higher embodied carbon, and it still allows for flexibility, so it shouldn't increase cost. So moving on from structure, I just want to highlight a few examples. Carpet is a great product to look for low embodied carbon options. Depending on your project, if there's a lot of carpet, we've seen projects that have achieved a 10% reduction across an entire new building just from carpet selection. So this is just comparing the embodied carbon intensity of a bunch of different products, but you can see there's a really big drop from the left side to the right side. Talked about this at the beginning, but really expanding bio-based materials. So there's a lot of content on here, but there's a couple really interesting examples of wood fiber-based insulations, compressed straw bale panels, mycelium insulation. There's some really interesting developments in the bio-based materials market. And most of the products are applicable for smaller scale residential projects, which is exciting because that's actually a large amount of the construction that's happening in the country every year. They're not necessarily, most of them are not necessarily available for the broader commercial market yet. I think they will be soon, but I think this is a place where the folks who work on the single family homes or the kind of smaller scale retail or commercial office buildings have a really interesting opportunity to advance the industry kind of from the bottom up. Switching over to facade, I think the key piece here is to really look at the materiality of the facade in addition to the entire backup attachment system. So the green part is the panel or the cladding piece. And a lot of times you see folks saying that, one material is much higher embodied carbon than another, which can be true. But maybe it also requires a less intensive backup system. And so I think that's part of what this is getting at, is once we include the support system, insulation, membrane, framing, all of that, you know, we really see that if we just looked at GFRC versus UHPC, we would probably have picked GFRC. But once we actually add the whole attachment system, we see that's much more carbon intensive. So again, taking a more holistic view as you're making these design decisions. One piece that often gets left out and that we're trying to bring more focus to is the HVAC MEP systems. This is just a characterization from a specific project, but what we've seen is for projects that have on-site renewable energy, the PV panels are almost always the biggest driver of embodied carbon. So then you get to a really interesting discussion of the embodied carbon impact of a strategy that is purely there to eliminate or offset operational carbon. And you kind of have to do a payback analysis of that embodied carbon investment. But I think it's a really, that's part of why looking at it holistically is so interesting and exciting, because you do start to see these tensions between embodied and operational, and the more important factor in the short term is going to be different depending on where you are around the country and the makeup of the grid that you're connected to. The other piece that often gets overlooked, but we see as the second largest carbon impact of mechanical or behind PV, is refrigerants. So there's a lot of good information out there about refrigerants. I think generally speaking, we're a little limited in the US, especially just because some of the lower GWP refrigerants tend to be higher flammability. And so there's still kind of market testing and safety testing that needs to happen for them to be available. But a lot of the principles that we already talked about apply to refrigerants. So employing passive design and smart system design to reduce the refrigerant need is really part one, right? That's the first step. And then specifying refrigerants with low GWP and really making sure there's no leakage or as low leakage as possible. Okay, I realize we're almost at time here, but I'm almost done. I just wanted to talk about a couple of the other areas that I think are really interesting to look at, but the landscape aspect of projects. So again, tight urban sites maybe don't have a lot of landscape, but again, so many of our projects are on college campuses or other types of campuses that have a lot of landscape design. And it's really interesting to look at the embodied carbon of landscape projects, because most landscape projects are not all plants, right? There's a lot of hardscape and infrastructure material that's required to make a park or a landscape functional. And it gives us this opportunity also to start to account for the sequestration, the carbon sequestration of the plantings that are part of the landscape project. And so, right, this is just an example of looking at the contributors to the embodied carbon of this landscape project. And paving and hardscape is obviously a really big component of that, but walls, right? It's like you don't often think that there's going to be a lot of walls in a park, but again, depending on a lot of factors, there could be, and there's really good opportunities to reduce the impact through some of the same concrete specification or product specification that we were just talking about. I think another layer of this for projects that are on even more rural sites or are part of a much larger open space site is looking at how land management contributes to carbon sequestration. So this is just an example of the calculations for a specific project that implemented land management strategies for what was previously grazing lands, grazing prairie lands, to restore it to a more functional prairie ecosystem, and how much carbon is sequestered through those practices. And then I think the last, where I want to end is just like, what happens when we put this all together, which there's a lot. But I think that's the point. There's a lot to, the more you kind of account for or address or look at in your process, the more opportunities you have to achieve reductions through interventions. So this is looking at a holistic carbon assessment for a project. So we've got the embodied carbon of the structure, the operational carbon from the energy used on site, embodied carbon of interiors, enclosure, and the foundation. So that's kind of like looking at, of all of our carbon emitters for the project, how are they distributed? What are we looking at? And then the outer ring is looking at the strategies that they've employed to achieve carbon neutrality. So they use mass timber on site, which offsets pretty much 100% of the structure, including the non-timber components. So there is still steel and concrete. They employed on-site renewable energy, which it offsets more than their energy use. They've employed the on-site carbon sequestration, and then the remainder they are offsetting. So absolute zero carbon does still rely on offsets in a lot of cases, but I think this is a nice place to end, just because it really shows kind of what happens when you do put it all together. The story you're able to tell. Any quick questions or anything? Oh, Paul has a hand raised. Here we go.
Hey there. Recently we put in some battery backup and solar on a project, and I'm finding that like 3-phase power for a smallish commercial building, like 12208 3-phase, is really complicated to put battery backup and solar on, because you need a different kind of panel. And I was wondering if you've run into that, where houses are getting too big to use single-phase power, and small commercial isn't quite cutting it with the 277, 480 3-phase panels that are out there and all that infrastructure stuff.
That's a really good point. I have not worked on that like niche size, right? I think it's a really interesting conundrum, right? You're kind of in between the two. And I think it just speaks to how the industry is still evolving, right? It's like we need something for that in between, because I'm guessing that's probably a lot of the demand is going to be in that scale. Well,
there's some questions in the chat, I think.
Oh, sorry, I didn't see the chat. I don't know why I can't see them. There we go. Oh yeah, there's the chat. Okay. See, carbon tracking and design. Have you used Cove? And no, okay. I have not used Cove tool. I just saw that they've added carbon tracking. I think there's so many tools coming out for different aspects of carbon assessment and tracking, that I think it can be really tricky and confusing. Full transparency, we use one-click LCA, which is a fairly expensive, robust tool that probably doesn't make a lot of sense for a lot of folks, but we just find that it gives us the most control and kind of visibility into the black box of assumptions. A lot of folks use Tally plugin for Revit, which is being connected through to EC3, which is a great procurement construction based tool to actually track kind of while you're buying products and looking at options when you're buying products. The two that I put up, Epic and Care, are kind of early stage assessment tools. And then I think Cove is, yeah, EC3 calculator. Yep. Sorry, I'm reading the questions while trying to talk, which is never helpful. But yeah, and then there's the tracking for portfolios or projects. There's Cove, and there's another one that I can't remember the name of. So I think it really just depends on what type of issue you're trying to address, which tool you would use. Looks like Ava has a hand up.
Hi, I'm Manisha from 196 Architects. Thank you, Amy. This presentation was really well done. I had a quick question. I'm working on a new construction building, and the solar panel requirement for new construction, does it have to be mounted on the building, or can they do site mounted?
I believe it can be, I know it can be on an adjacent structure, like a parking canopy. And so I would imagine that it could be site mounted. I think the concern with site mounted is the permanence of it, right? And if there's plans to maybe develop that land in the future, then the site mounted system would go away.
Yeah, so this is in Paso. There are plenty of site, and they're planning actually offsetting entire campus with that one solar panel system that they're going to put in. Like, it's going to be one project for the entire campus. So I can still budget the solar storage and battery storage as part of this project, but then the panels, I can take that from the site ones, right?
You're gonna have to talk. So I've actually had this issue on a project. You have to talk to the CEC about it. I think it depends on if it's new. So if they're putting in new panels as part of the building project, they might allow it. We asked this question for a new building on a university campus that already has an existing huge array that there's plenty of availability, and they would not let them use that. They are requiring them to put PV and battery at the building.
That's interesting. Thank you.
Mm-hmm. I think there's a question about the first picture. It was just a pretty picture. That it's a project we worked on. Just in the cover slide. That's the Natural History Museum. Yeah. Okay. Well, I know we're a little bit over. I think we addressed the questions in the chat. Unless there's any other burning questions, we can let everybody go. Great. Thank you.
Well, thank you so much, Amy.